welcome to Starbucks. How can I help you?
Hi, can I have a tall half soy latte at 120 degrees, please?
Can I get a name for that?
It's crunchy, just crunchy Hunsche.
All right. There you go.
Have a nice day. Why did this fall like that? This always happens.
Crunchy Hunsche was furious. Nobody ever spelled her name right. This led to her hatred of cups. At the juice convention, Crunchy wore a sign warning everyone to keep cups away from her to prevent an outburst. The sign read, "Keep away from cups." But then a terrible accident happened. The juice spilled all over her, and her life changed forever. Suddenly, she could double in size.
For linear momentum, this consists of our villain doubling herself and doubling in mass, which therefore increases our linear momentum. For this case, we are using the equation P equals mv for linear momentum, which incorporates the physics principles for magnitude and the law of conservation. And with this, we can take Charlotte's mass of 50 kilograms and multiply that times 2, giving you 100, which therefore doubles your linear momentum in this case, making Charlotte more powerful. For this case, we are using a graph that shows how force changes as your mass changes, and the force increases when your mass increases. For dynamics, Charlotte has superspeed, and this means that she can increase her velocity over time to escape anything that she needs. For this, we use F equals ma as our equation, and we plugged in her mass of 50, and we set it equal to 2,000, which is the force that the cup can exert. Therefore, we solve for her acceleration, which is 40 meters per second squared, which is much faster than any average human could go. For this, we also use a velocity versus time graph, showing that as time increased, your velocity also increased. And as for fundamental physics principles, this relates to Newton's second law, as well as acceleration. For rotational motion, we have what we call the torque attack, meaning that she can rotate any part of her body in a straight line while also extending the length, therefore exerting a torque on an object. For this, we use torque equals force times radius. We plugged in the force of 2,000 as well as the radius of Charlotte, which was 41. We used 2,000 because of the previous force exerted to try and match the cup. And this gives us 82,000 newtons times centimeters. In terms of physics principles, this relates to angular momentum and moment of inertia. We also related this to a force times radius over time graph, showing that over time, your force and radius increased with the power being used.
But Crunchy Hunshe's fear of cups was justified because one day they attacked, and she was ready for them. It was a tough fight, and Crunchy's femur was injured in the process, but in the end, she persisted and she won.
In order for the cup to break Charlotte's femur, it has to obtain 4,000 newtons, and with the cup weighing 0.1 grams, it has to accelerate at 40,000 meters per second squared, resulting in a force of 4,000.
With a swift kick to the stack of cups, Crunchy Hunsche redeemed herself even after her injury. And thus ends the story of Crunchy Hunsche and the scary cups.
If I die, it's for physics.
Okay.
Doctor.
It's not gonna hurt you.
Okay, can you take this?
And I'm not helping you clean this up.
And scene.